All right, so multiplicity. So this is 4.4, I believe B. If not, then it may be the end of A, I don't know. So when you have a, guys, when you have a polynomial written in factored form as x minus c to the k power, if k is greater than or equal to 1, we say that there is a multiplicity. And based on whether k is odd or even determines how the multiplicity affects the graph, okay? Make sure you're paying attention and ask questions if you're confused. So if k is odd, that means the graph crosses the x-axis at c at the root. So it's going to cross at the root. Okay. If k is even, then the graph is tangent, which means that it's going to touch the axis instead of cross the axis. So instead of crossing, it's going to touch. Okay. So we all know our odd numbers. We all know our even numbers, right? We don't need to go over that. But if the power of your root is greater than or equal to 1 and it's odd, it's going to cross at the root. If the power of your root is greater than or equal to 1 and it's even, it's going to be tangent, which means it's going to touch the axis. It's going to sit at that exact point. Okay. So we're going to do some examples here. It says write the complete factored form for the 5th degree polynomial shown in the graph. Assume that all zeros are integers and that the leading coefficient is +1 or -1. Okay. To determine your leading coefficient, you're looking at your end behavior. Okay. So if I end negatively, then my leading coefficient is negative. If I end positively, then my leading coefficient is positive. Does that make sense? So your end behavior of the graph. So we read graphs from left to right. Where is your graph heading towards? It's heading towards negative infinity, right? It's decreasing. So it ends negatively. So that lets me know that my A value has to be a negative because it's ending negatively. So when it says, what is your leading coefficient? Is it +1 or -1? Our A is -1 because the graph is ending negatively. Okay. It tells us we have a 5th degree polynomial. So what that means is that the powers of our factors should add up to 5. So it's a 5th degree polynomial. So the powers of our factors should add up to 5. Well, we have a root here at -2 and a root here at +1. Do we see that? So that means that at x + 2 and x - 1, something's happening, right? So at x + 2, it touches. It's tangent. So therefore, this has to be x + 2 squared. If my 5th degree, if it's a 5th degree, and I know that this is 2, what does this mean? This have to be in order for those powers to equal 5. 3. So the multiplicity here is 3, which makes sense because it crosses. It doesn't touch, it crosses the x-axis. And my leading coefficient is -1. So this would be my function. The x + 2 is squared because it touches the x-axis. It doesn't cross the x-axis, it touches. And so right here, we said that if your k, which is greater than or equal to 1, if it's tangent, so meaning if it touches the x-axis, your power has to be even. Does that make sense? So my power has to be even. So therefore it has to be k equals 2 in this case. Okay. Questions so far? So again, you're paying attention to whether it crosses, how it crosses. When I knew that I had a 5th degree polynomial and I needed to be squared because I'm touching. And if I'm 5th degree and I know this is 2, together my multiplicity has to equal 5. I know that my leading coefficient is negative because from left to right, my function ends going down in the negatives. is decreasing. So A has to be -1. What are your questions? So remember, the multiplicity rule is key. All right, here, this is just an example of how a polynomial function can look using pi. We're not going to worry about it, so we're just going to head and keep it pushing. All right, now we're talking about the rational zero theorem. Okay, if a polynomial equation has integer coefficients, then any rational zero must be in the form of plus or minus p divided by q, where p is the factor of the constant, so your last term without a variable, and q is the factor of your leading coefficient. Okay, so the number with the highest power. So when you're determining what your possible rational zeros are, it equals plus or minus p divided by q. So p over q. Think alphabetical. Okay, I tell you think alphabetical, but to me it's always backwards when you're looking at it. It's the constant over the leading coefficient. Okay, so your factors, your factors here are 3 and 1. So how I write it is I would write it as 1 and 3 are the factors of 3, right? The factors of 2 are 1 and 2. And all you're doing is making all the combinations of fractions from these numbers. So you have 1 divided by 1, which is 1. 1 divided by 2, which is 1/2. Then you have 3 divided by 1, which is, and you have 3 divided by 2, which is 3 over 2. And it's their plus or minus. So one of these 8 numbers is one or more of these 8 numbers is a root, a perfect root to this polynomial. So that's your rational zero theorem. Do you think you can identify the factors and then create the possible factors? All right, well, let's try it again. So we're going to do it. So I'm going to start off with my p. So it's p and q. So we have f of x equals -10x cubed minus 17x squared plus 7x plus 2. So we're going to figure out what are our possible factors, okay? And remember, it equals, so it's p over q, so plus or minus. And the factors of 2 are 1 and 2. The factors of 10 are 1, 2, 5, and 10. Okay, I'm going to go through and do them all, and then we'll eliminate duplicates. Is that okay? So we have 1 divided by 1 is 1. 1 divided by 2 is 1 divided by 5 is 1 divided by 10 is, and then we're going to do the same thing with 2. So we have 2 divided by 1 is 2 divided by 2 is 1. And then we have 2 divided by 5, and then 2 divided by 10. So my duplicates are, so I can, my 1's duplicate, and so does my 1/5, 2/10. So all of these are all my possible real zeros. So we have plus or minus, and I don't want to write it all over and over. So I just kind of put parentheses, 1/10, 1/5, 2/5, 1/2, 1 and 2. So one of these 10 numbers is a perfect root. And you just have to decide which one you want to start off with. So I like to start off with numbers that are easy. So personally, I want to start off with 1 and 2, right? So when it says then factor, that means you're going to do synthetic division. So you're going to choose one of these numbers to start off your synthetic division with. So I would choose, let's start with 1 first, right? So if I choose 1, I'm going to plug it into my synthetic division. I have -10, -17, 7, and 2. Are we all still good with synthetic division? So I'm going to bring down -10. 1 times -10 is? -17 plus -10 is? 1 times -27 is? 7 combined with -27 is? And 1 times -20 is? And this equals -18. If it doesn't equal 0, that means that 1 is not a root. So does this equal 0? No. So this is not a root. Okay. So you're like, all right. Well, what if I tried -1? So I'm going to try -1. Let's see what happens. So I'm going to have -10, -17, 7, and 2. Bring it down. -1 times -10 is 10. -17 plus 10 is -7. -1 times -7 is 7. And that gives me 14, and -1 and 14 make -14, and that's -12. Is that 0? No, it's not. So that means 1s are out, right? +1 didn't work, -1 didn't work. So what should we try next? Want to do 2s? So I'm gonna do
Is more than one gonna be a root or just one of them?
more than 1. You can have up to 3 of them because what is the degree? Your degree tells you the maximum. Oh, I meant to write that it's not 0 and it's 12. It's -12. My bad. Okay. As I'm going, I see that this is not ending well. That did not end well. So did 2 work? No, did not. I need to erase. I ran out of room. You have whole papers. I keep going. My paper doesn't keep going. All right, I'm going to try -2. And if all else fails, I'm going to have to move into my fractions. So we have -10, -17, 7, and 2.
Where did 34 come from?
Right, I was just looking at that. Why you not 34?
What'd I write?
You put 34. Isn't
Oh, I don't know.
it data 37 times 2?
I don't know what happened there. Either way, it doesn't work.
You gotta do that. You don't know the work for life.
I got 74. It's even bigger. 37 times 2, right? I was like, either way, failure. Okay, failure. It didn't work. All right, negative times a negative is a? So we get 20. -17 and 20 is? -2 and 3 is? 7 and -6 is? -2 times 1 is? And what?
Yay!
We found it. We found it. But we found one of our roots. Yes. We found one. We found -2. But the beauty here is that you don't have to do another synthetic division. You can just do quadratic formula at this point because it's an x squared plus 3x plus 1. So you now could just switch to quadratic. If you don't want to do quadratic, you also have the box method. You also have grouping, whichever one you want to do. So what do y'all want? Quadratic. So we have x equals -3 plus or minus the square root of b squared minus 4AC divided by 2A. That's A. So it gives me -3 plus or minus the square root 9 plus 41. Is that right? Oh, 9 plus 40? I don't know. 49 all over -20. Yes. Nah, I ran out of room. Let's put you right here. So that leaves us with -3 plus or minus 7 over -20. So which one of these is that? Quadratic formula? Remember quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac divided by 2a.
Okay, I kind of remember that.
Yes, you did. You
But
did.
I don't remember.
There's my a, my b, and my c.
We did this like 2 weeks ago.
Yeah, you did like 3, 4. Well, she did. Yeah,
Oh, the way I was talking, okay, so what numbers did you put inside?
we had a whole test on it, exactly.
I always thought to just solve the quadratic.
Yeah, you can solve, that's what I said, you could factor it. Yes, I taught you factoring also. Yes, huh? Where are the 3? Right here? My b is 3. When we had -17 and 20 made 3. So this is my a, my b, and my c. And you plug the variables where they go. So then now you do the math. What's -3 plus 7? -3 plus 7. -3 plus 7. 4, guys, 4. I didn't hear you. 4/20. What's -3 minus 7? -10. So based on a negative times a negative divided by a negative is a positive. So our answers are, out of our choices here, what is 4/20 reduced to? 1/5. So we have -1/5 is a winner. We had -2 was a winner. And what is 10 over 20 reduced to? 1/2. And those were our answers.
Okay, what's the other way?
Yeah, I'm writing it out. It's just one problem.
What's the other thing? The other way?
Instead of using quadratic, you can do grouping or Xbox. So if you didn't want to do quadratic, I was about to erase it. I kind of erased part of it, sorry. So if quadratic formula is your catch-all, it's gonna always work, even, as long as you multiply correctly. But if you are, like Devin said, we also learn how to do other things such as Xbox or grouping. So if you chose to do one of the other ones, so if you chose to do, let's say, grouping. So you have -2x squared plus 3x plus 1. You ask yourself what multiplies to give me -10 times 1, which is what? What multiplies to give me -10, but adds to give me 3x.
-5 and
Switch it.
-2 is 5.
-2 and 5, right? So if you, maybe this rings a bell, maybe setting up the box. Does that ring any bells? So you would have -10x squared, 1, and we have +5x and -2x. Do you remember the box? So you have -2x, you have 1, you have -5x, and you have 1. -1. So then these are your factors. So you have to solve them, it's negative 5x minus 1 equals 0 and negative 2x plus 1 equals 0. And that's how you end up with what your zeros are, which is what we said, x equal 1/5, right? Negative 1/5. And we ended up with x equals positive 1/2. So if the quadratic doesn't work, then of course you have solving by hand always. I mean, you solve by hand technically on all of it, but. All right, how do we feel? No? All right, so we're going to talk about how all this comes into play. So what this allows you to do is you have your zeros. You know that they only are, since you have 3 zeros, third degree, that all of them are going to be utilized. You have your y-intercept. Basically, you can draw a sketch of your graph given everything that you have. So here we have x cubed plus 6x squared minus 7x. And so if I wanted to find the zeros here, this time, notice that I do not have a what?
No, you don't have a C.
I don't have my constant, right? I don't have a constant. So that P over Q would be 0 over 1, right? So that means the only thing that I have is 0, right? So in this case, it would just say, okay, well, one of your zeros is at 0. I'm like, yes, I know that. Good job. Okay. So this right here, though, this is a good old fashioned, I can factor. So we have x cubed plus 6x squared minus 7x. What's the GCF here? X. So I can factor out an x out of everything. So I'm left with x squared plus 6x minus 7 equals 0. What multiplies to give me negative 7, but adds to give me positive 6? Is there what kind of 7 and 1?
-1.
A negative 1 and a positive 7. So I now know where all my zeros are, right? So I have a 0 at 0, which we already knew. So at 0, 0, we have an intercept at 1, 0, and we have an intercept at negative 7, 0. So therefore, these are my solutions, 0, 1, and negative 7. Okay, what it says graphically and numerically, that means looking at the graph and looking at your table. So let's look and see what this looks like on the graph. So we're going to graph x cubed plus 6x squared x cubed plus 6x squared minus 7x. And hit graph. And if I did it right, I should cross at 0, 1, and negative 7. Do I cross at 0, 1, and negative 7?
No.
Yeah. Yes. So this is your graphically. Does that make sense?
Oh.
Right here? Boom, boom, boom.
Yeah.
So this is graphically. When it says numerically, that means I'm looking at a table. So if I go to the table at negative 7, does my y equal 0? Yeah. If I go to 0, does my 0 equal 0? If I go to 1, does my 1 equal 0? Yes. So you did it symbolically and you checked it graphically and numerically. Yes?
Yes.
Terrible?
No.
Okay. All right. So here's just find all the real solutions. So this one is a little different. Again, here we have I can't talk, a quartic, not a quadratic, it's a quartic. And the reason why it's a quartic is because it's a degree of 4. Do we see that? Instead of just a square. So on this one, if I wanted to find my potentials, I do have my constant now, and I do have my leading coefficient, right? I will have to add 2 zeros once I start doing the other stuff, right? But do I have to do it right now? No. So we have P over Q. So that's -12 is my P, 9 is my Q. What are the factors of -12? Right? 1 times 12, 2 times 6, 3 times 4. Right? All right. What are the factors of 9?
30. Oh, wait, 1, 30, 9.
That's it, right? So then my possible values are 1 divided by 1 is, 1 divided by 3 is, 1 divided by 9 is, and then I'm gonna do the same thing for everything else, right? 2 divided by 1 is, then we have 2 divided by 3 is, 2 divided by 9 is, then we have 3 divided by 1 is, 3 divided by 3 is, 3 divided by 9 is, 1/3.
Oh, it's my fault.
It's all good. 4 divided by 1 is, 4 divided by 1 is,
4,
4 divided by 3 is,
4,
4 divided by 9 is, then we're on 6. 6 divided by 1 is, 6 divided by 3 is 2, and we already have 2. 6 divided by 9 is, which is
3 over 1 over 2 over, no, 2 over 3.
and I already have it, so don't need to write it. No. 12 divided by 1 is,
12,
12 divided by 3 is,
4,
got it. 12 divided by 9,
12, 9,
which reduces to, flip it,
4/3.
4/3. So I already have 4/3. Yes. So these are all my possibles plus their plus or minuses, right? Of real roots. Okay. So I would go through and I would figure out, okay, let's do blah, 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 blah. All of those are my possible. Now, when I look at this, I can kind of cheat a little bit because this isn't a pattern of a quadratic. So when you think about quadratic, you know how it goes square, 1, 0. This goes 4, 2, 1. And it's because I have the 4 and I have it square. That means that I actually can use the quadratic formula to narrow down exactly which one is a real root. So you could use the quadratic formula if you wanted to try to shortcut your way through it instead of having to do synthetic to figure out which one is correct. Because look right here, if you choose the wrong number doing synthetic, that's a lot of work, right? So if I can use quadratic, why not use it? Okay, so for quadratic, I would have x equals -b, which is 23, plus or minus the square root of b squared minus 4ac divided by 2a. I'm going to plug this in the calculator. So I'm going to plug in 23 squared minus 4 times 9 times -12. And what do I get? 961. See if that's a perfect square. Square root of 961 is what? It's 31. Look at that. It's a perfect square. So now I'm working with -23 plus or minus this 31. 31 over 18. So I have -23 plus or minus 31 over 18. And what do I get? Well, let's see. -23 plus 31. 8. So that gives me 8 over 18. So 1 is 8/18, which is 4/9, right? Did we say that was possibly one of ours? Yes, we did. And then the other is -23 plus 31. So we have -23 minus 31, I'm sorry, minus 31. I was like, I already did that. And that gives us -54 divided by 18. And -54 divided by 18 is -3. And did we say that 3 was one of ours, plus or minus 3? And so since this is a quadratic like form, these are our two answers. So we have 4/9 and -3. And did we say that that's how you know you're right? Were they one of my possibilities? Yes, they were. I find it fun. All we did was add and subtract. In the beginning, all we did was divide, simple division to give us basically you're creating your own multiple choice, right? So here's my multiple choice. And then we did the quadratic to figure out which is the correct answer. That's it. So that means that these have to be double. So that means that they have a multiplicity of 2. Multiplicity. So they have a multiplicity of 2. Don't say that. You got this. All right. All right, so the bell's gonna ring. I was gonna make you do this one as your exit ticket, but we're not gonna have time. We're not gonna have time.